Hello and good morning to everyone. So our today lead code question is 2130, that is maximum twin sum of a linked list. So basically in this question we are given a linked list having size n and it is given that n is even number, right? And the ith node is basically, and the linked list is starting from zero indexing, right? So the ith node of the linked list is known as the twin of n minus I minus one node. So that means if we have zeroth node, so zeroth node is twin of n minus 1 node, first node is twin of n minus 2 node, second is twin of n minus 3 node. So basically first and the last nodes they are twin, then second and second last they are one twins, then third and third last they are twin. So in this way we have the twin pairs, right? So and the twin sum is basically the sum of a node and its twin sum. Sorry. So the twin sum is basically the sum of a node sum and its twin node sum. And so we are given the head of a linked list, we have the head of a linked list with the even length. Now what we do need to do is we need to return the maximum twin sum of the linked list. So let's see the example. So we have this linked list. So what are the twin pairs? 5 comma 1 is one twin pair, that is these two nodes, and then other is 4 comma 2. So this is the second twin pair. So if we see the sum of 5 comma 1 is 6 and 4 comma 2 is also 6. So maximum of 6 comma 6 is 6. So 6 is our answer. So we need to return the maximum twin sum, right? So let's see the second example. So here we have only two nodes. So if we have two nodes then they will be the twin of each other, right? So we directly sum these two nodes. So we get, and this is our answer. So this way what we need to do is we need to return the maximum sum of the twin pairs out of all the twin pairs, right? So let's see the constraints. So we can have total, we can have from 2 to 10 ki power 4 5 nodes, and the number of nodes is even, and each node can have a value from 1 to 10 ki power 5, right? So let's move to the approach part. So the twin of a node is basically the node at the same distance from the end of a list. So suppose if this node is at one distance from beginning, then its twin should be at distance 1 from the end, right? So these will be the twin pair, right? And this is having distance 0 from the beginning, this is having distance 0 from the end, so these will be the twin pair, right? So we get the twin pairs. Now as we know, in a singly linked list we can only move in the forward direction, right? We can move in the forward direction using these pointers only, but but here we need to compute the twin sums. So what we need to do is we need to access the twins simultaneously, like in the forward direction as well in the backward direction from the both the ends, right? So what we need to do is if we somehow we can start iterating here in the border direction, but due to the linked list we cannot traverse in the back direction, we can only traverse in the forward direction, right? So that's a challenge. So let's see how we'll handle that. So if we somehow reach the n by 2 node, means half the nodes, and then from that there what we do is, so suppose if we have this linked list, having 6 nodes, if we somehow reach here, that is up to the half, so this half and this half, and as we know these are the two twin pairs, these are the two twin pairs, and these two are twin pairs. So if we have two pointers here, and then what we do is this pointer will somehow move in the backward direction and this pointer keeps shifting in the forward direction simultaneously, then using these two pointers we can get the sum. right? So first we get this sum AB, then compare this with the result, then this will shift in the backward direction, it will reach to this point, this will shift in the forward direction and it will reach to this point, and then we get this sum. So we need to we need to somehow shift, take two pointers and then such one pointer move in the backward direction and one pointer move in the forward direction. So to to get this thing, what we'll do is we'll use the recursion. So in recursion we basically maintain three pointers. First pointer is head pointer. What it will do is it will move one step at a time, right? That is, we shift head from head to next pointer only. And what it will do, it will represent the nodes from the first half, right? The head will represent the nodes from this first half, right? And then we have the other pointer, that is P. So P is basically a fast pointer. P is basically a fast pointer, and it will move two steps at a time, two steps at a time. And P is used, it will be used to stop the recursion, or we can say stop our head point at at n by 2 minus 1 node, because we have at n by 2 node, right? At n by 2 node. So what we will do is, so suppose we have a linked list, right? Let's see, we have a linked list having four pointers. So initially our P and head both are at 0. Then in the next iteration our head will come here, and then our P will come here, because it is moving two steps at a time. Then in the next iteration our head will go here, our P will point here at null pointer. So once P will point at null pointer, then at that time we stop. So we see our P is pointing here when our head is pointing here when our P is pointing at null pointer. So this P pointer, which is a fast pointer, is used to stop the recursion at the middle of the linked list. And then there is a third pointer Q. What it does is it will represent the nodes from the second half, right? And see, here in the example we have discussed two pointers, that we need two pointers, one will move in the backward direction and one will move in the forward direction. So this pointer that will move in the backward direction would be head, and that the one which move in the forward direction will be Q. So let's see how we'll handle these pointers, right? So once the fast pointer, that is P, it reaches the end of the list, that means our head pointer reaches the half of the list, right? Half of the list. So we stop recursion at that time. So let's try to understand with the help of an example, right? So initially when we call the function, our and head P and head both are pointing at 0, and our Q is equal to null pointer. So this is when we call the function, right? Recursive function. Then in the recursive function state 1, so this is state 1 of our recursion, where head is equal to 0, P is equal to 0, like I am writing the index, right? And our Q is equal to head arrow next. So we have head at 0, so Q will become 1. Then we again call the function shift head by one pointer ahead. P is our first pointer, so it will be shifted by 2 points, and Q will remain the same. So this is again the function calling. So this function will land us in recursion state 2, where our head is 1, our P is 2. Now we have to make Q is equal to head arrow next. So if head is 1, then Q arrow next will become head arrow next will become 2. So our Q is equal to head arrow next, so Q will become 2. Then again we call the function, so in the next function calling, head should have become 2, P is 4, and Q will remain same. But now this 4, there is no fourth node here, the nodes are up to index 3 only, right? So this 4 is pointing to null pointer, right? Null pointer. So what we do is, so we stop recursion here, we stop recursion at this point, and what we do is we'll backtrack. So when we backtrack, we'll move to the previous state, which is recursion 2 state. And as we know, in recursion 2 state we have head equal to 1 and our q is equal to 2, right? So when we stop recursion, our head is pointing here, head is pointing here, and our q is pointing here, and that is what we want, that somehow we divide the linked list into two halves, right? And we have two pointers, so we have two pointers, head and q. And now what we'll do is we'll take the sum of head and we'll take the sum of these two pointers. So head is at 1 and q is at 2. So at 1 we have value 2, and at 2 also we have value 2. So 2 plus 2 is 4. So now we, our sum is 4, this 2 and sum is 4, so we compare it with the result. So initially we take the result is equal to 0. So now 4 is greater than our result, so we update our result to 4. Now next thing what we do is we will shift q is equal to q arrow next. So earlier our q is equal to 2, so when we shift to q arrow next, our q will become 3. Now q is, our q pointer is pointing at 3, right? Q is pointing at 3, and then we backtrack to recursive state 1. So in recursive state 1, we have, so if you see in recursive state 1 we have head at 0 and q at 1. In recursive state 1 we have head is equal to 0, q was 1, but we have updated q to 3, right? We have updated q to 3, right? For q we are using ampersand, right? So this is, we are using ampersand, that is we have made an alias. So when we update q is equal to 3, so in recursive 1 state q was 1, but it has been updated to q is equal to 3. So now we have head is equal to head at 0 and q at 3, right? So we take sum is equal to 4 plus 3, that is 7. So 7 is greater than result, so we get our result equal to 7. So we get our answer, that is 7. So let's move to the code part, right? So this is our main function. So if we have only two nodes, that is head arrow next is pointing to null pointer, that means we have only two nodes. So if you have only two nodes, then they will be twin of each other, so we directly take their sum and return that value. Their value. Now if you have more than two nodes, then see, we have taken a p pointer which is initially pointing at head, and then we have taken a q pointer which is pointing to null, and then we have called the function head, p, result and q, right? Now see what this traverse function will give us. So if you see the traverse function, here we have head, we have p, here we have result. So we see we have used ampersand with the result, here we have q, here is also we have used ampersand with q. So what this ampersand will do, so this ampersand will help us in way such that at any point in recursion, if we update value of result or value of q, then that updated value will be available to all the states of the recursion, right? As we have seen in the example earlier, in a recursion 1 state we have q is equal to 1, but when we updated q to 3, then that updated value was available in that state also, right? So no matter what we have value of q at that state, but once we update value of result and q, then that value will be available to all the states, right? So here we see if p is not equal to null pointer, that means once our p becomes equal to null pointer, then we stop the recursion and go back. But if it is not equal to null pointer, then we update our q to head arrow next, and then we shift Then we again call the function shift head by 1, shift head by 1, shift p by 2, and then result and q value is same, right? And then when we return back, like when we retrack back, then we check head arrow value and q arrow value. If the sum of these two values is greater than result, then we update our result. And see, here we are updating our q pointer to next, q arrow next, right? So when we retract back, our head will shift in the backward direction, but our q, we are updating our q, so will q will shift in the forward direction. So with the help of pointers, we have done the solution efficiently, so we do not need to reverse the second part of the linked list, right? So I hope I'm able to explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.